Another thing that helps with integrals that you don't know how to find the antiderivative of is to recognize when the integrand is an odd function. And you can use symmetry to solve it. So remember that an odd function is symmetric about the origin. So that we've seen this before when we looked at Riemann sums. If you have an odd function on an interval such as like -2 to 2, where you have it ends at the negative, so 2 is the opposite of -2, because the height of the rectangles here are negative values, yet they're the opposite of the height of the rectangles here, we saw that they canceled out, right? So that this definite integral was going to have a net area of 0. So if you can recognize that the integrand is an odd function and your limits of integration are need to be right so that you have that symmetry so that the net area is 0, then you can just quickly identify the definite integral as 0. So let's look at an example. X cubed plus x to the 4th tangent x. I'm from minus pi over 4 to pi over 4. So notice that this interval, I have this pi over 4 units to the right of the origin and pi over 4 units to the left of the origin. So this interval is just right. And that this is an odd function because x cubed is odd and x to the 4th tangent x is odd because tangent x is an odd function. And we can prove that here. Since minus x to the 4th power is always just x to the 4th, and tangent minus x is minus tangent x because tangent itself is odd, I get that this entire function's an odd function. So because it's symmetric about the origin, I know that the answer to this is 0. So the odd functions, if the interval of integration is right, it's nice that the solution's just 0. So it's not quite as handy with even functions because remember that the symmetry of even functions tells us that the value of the definite integral on an interval that is symmetric about the y-axis is double the integral from the y-axis to the upper limit. So for example, look at cosine, the integral of cosine x dx. Cosine is an even function. And if I look at it from minus 2 pi to 2 pi, I have the same distance along the x-axis to the right of the origin as to the left. So I can say that the definite integral from minus 2 pi to 2 pi of cosine, there should be an x there, cosine x dx is twice the definite integral from 0 to 2 pi. So that's not as handy as odd functions because with odd functions you don't have to do any work. You say, oh, the definite integral is 0. Here with even functions you do still have to find the antiderivative just on half the interval. So in summary, the substitution rule, you might need to try a couple different substitutions. Often the inside function of a composite function is a good candidate. And remember, you need to get every part of an integral in terms of your new function u. So the dx and every factor needs to be in terms of u. And also with definite integrals, don't forget to turn the limits of integration into terms, put those in terms of u as well by evaluating your substitute function u at the original limits of integration.